Alrighty, we are on video number 3 and the last video for today. We're going to start looking at area of circles, and we're on page 623, just like the agenda says. So we are going to work through this first page and just review circumference and area both, because that's what it's going to start with before we actually talk about the area of a circle formula. And so again, you need your calculator. We will be using that here shortly. But right now, let's start looking at and reading through 623. So your real world link with area of circles. Here's your little story. Adrienne bought an 8-foot leash for her dog. And so you can see that in the picture off to the right. And in number 1, Adrienne wants to find the distance the dog runs when it runs in one circle with the leash fully extended. Should she calculate the circumference or the area? So a couple key pieces here. First off, right, you notice that leash, there's a center point and the leash is attached to that center point, and then it's extended fully out. And so what you're looking at right now actually is the radius. Okay, so as that dog is running around in the circle, round and around, right, tiring it out, then knowing we're looking for the distance around the circle, the distance the dog runs when it runs in this circle, okay, we're looking at circumference, right? That's what we just covered in lesson 1. So circumference is what we're finding, and that's what she should measure for. And circumference is the distance around the circle. That's why we're using it. So you should be filling this in. This is a good review for lesson 1. And so if she were to truly find the distance that the dog's running in that one circle, she's using this formula that we learned the last couple days. Circumference equals pi times diameter. Distance around, super important, understanding that word, distance around, that is your circumference, the perimeter around the circle. Okay, number 2. So suppose she wants to find the amount of running room the dog has with the leash fully extended. Should she calculate the circumference or the area? The amount of running room the dog has, okay? So now in this case, we're looking at area. She's going to want to figure out the area to see the amount of running room, the inside space here, the inside space inside that circle. Area, because it's the space inside the circle. Oops. Okay, space inside the circle. So if that dog starts running around inside, that's what she's trying to see, the amount of running room, area. So this is lesson 2. And so we're going to learn this formula here shortly. We'll go back to that and we'll talk about that on the next page. Now, number 3, describe a real-world situation that would involve finding the area of a circle, right? And there's lots of different examples that you could come up with and that you might be thinking about. Obviously, since I'm doing this on video with you, I'm going to give you one of my examples that I'm thinking about, but you might have something completely different, and that's great. So involving the area of a circle. So what if I wanted to compare pizzas? So, I'm getting ready to order pizza from, let's say, Glenside on Sherman. And I'm trying to figure out the difference between a 10-inch and a 12-inch, right? Like, how much more pizza is in a 10-inch pizza compared to how much pizza is in a 12-inch, which would be the better buy for me, for my family. And so if I'm doing that, I'm comparing the amount of pizza I know I apologize with this pen. Sometimes my handwriting looks really bad, but it's just the way that I'm grasping it and how it writes, so I do apologize. Amount of pizza in a 10-inch. To the amount in a 12-inch. Okay, comparing pizzas, the amount of pizza in a 10-inch to the amount of pizza in a 12-inch. That would be one example of finding the area, because your pizzas are in circular shape. Number 4, describe a real-world situation that would involve finding the circumference of a circle. Okay, so number 3 talked about area, right? Finding the area, real-world situation. Number 4 is talking about real-world situation with circumference. So again, I'm going to give you one of my examples that I'm thinking of, but I'm sure you could also think of other possibilities. So if I'm going to put a garden in my yard and I want to put fencing around it because of all the deer that is in our neighborhood, and I know if I don't try to put some fencing around it, the deer is going to get in there, or the rabbits, and eat what I'm planting, right? So an example would be measuring distance around a garden. Oops. For fencing. Right? I need to know if I'm going to put fencing around that garden, I need to know how much fencing to buy. And so by me finding the circumference around that circular garden that I'm going to create, I need to know that distance around that circle so I can buy the appropriate fencing that I need to put up around it. Okay? So you can pause to catch up if you need to. Otherwise, we're going to head to the next page. So I'm going to scroll to 624. And now we're going to talk about finding the area of a circle. So we're going to look at this formula here. And at the very top, it says the area A of a circle equals the product of pi and the square of its radius. So here's our formula. Area equals pi r squared. R is that radius. And so I gave you a little thing to remember for circumference for the formula. I'm going to do the same thing with area right now. So I'm going to write apple pies are 2. So the way I'm using this is the A in apple stands for A, area, in the formula. Pies is standing for that Greek symbol pi. R is the radius. And the 2, the exponent of 2, TOO, okay? So if you think about it, off to the side here, remember I talked about circumference, right? Cherry, pies are delicious. And that was because this formula for circumference. And then if I finish this, comma, apple pies are 2. And that goes with my area formula. Pi r squared. Okay. Cherry pies are delicious. Apple pies are 2. Cherry pies are delicious. C, circumference equals pi times diameter. Apple pies are 2. area equals pi times the radius squared. All right. Made a little mistake. That looked kind of weird there. There we go. Okay, so now we have another formula to know and practice and work with. And so let's try this area formula. And again, you need your calculator right next to you so we can work through some problems together. So we're going to scroll down and go to the bottom of page 624. We're going to look at the got it, okay? So it says, find the area of a circle with a radius of 3.2 centimeters, and we're going to round to the nearest tenth. So you don't have to draw a visual if they don't give you one. It's fine. You can work the problem out with just the story. Or if you need to see what that looks like, right, you can draw it. And this has a radius, right, from the center point there of 3.2. And it's centimeters. All right. Now, knowing our formula is this, area equals pi r squared. We're going to start plugging in what we know. So area equals, we can use the pi key on this, times the radius squared. Well, we have the radius. It's perfect. So this 3.2 squared is what we're going to do. Now I'm going to put that radius, that 3.2, in parentheses there, so you understand that you're only squaring the radius, just this number right here, 3.2 squared. Now, when we work this problem out, we actually have to think about order of operations, which means you have to do your exponents first before you then multiply. So on your calculator right now, 3.2 squared. So if we do 3.2 times 3.2, remember when you square a number, you're multiplying it by itself. 3.2 times 3.2. And hopefully what you see is this value right here, 10.24. That's taking care of the exponent first. Multiply it by itself. When you get that value, now you're going to multiply it by pi. So we'll use the pi key here. Now you're going to see me in this lesson go back and forth between the pi key and also using 3.14. So I need you to get comfortable with using both and understanding the difference between both. And again, remember, there's not much of a difference. The pi key is the exact amount, infinite number, infinite decimal, and the 3.14 is just rounded. This problem, we're going to use this pi key. So now 10.24 times the pi key on your calculator. And when you do that, here's what you start to see. The area inside, right? So I'm talking about inside the circle here, area inside, right? You start to see 32.1699, and it just keeps going because you're using that pi key. We're going to round to the nearest tenth. That's what it's asking us to do in the directions here. So that means I look at the hundredths, I look at the 6 and the hundredths, and that tells me what to do with the 1 in the tenths. Well, since there's a 6 there, it's going to round it up. Okay, that 6 is going to round that 1 up to a 2. So final answer here, I'm going to write it off to the left. Area equals of that circle, 32.2. That 6 is going to round that 1 up to a 2. 32.2, and this is now centimeters. Now, anytime you find the area, it's square units. So centimeters squared. Area equals 32.2 centimeters squared. Okay, let's try another one. So we're going to go to the next page, which is 625. And we're going to take a look. Let's see. You know what? The got it at letter B there. So 625, letter B. So here you have a little bit of a story problem, and it says the bottom of a circular swimming pool with a diameter of 30 feet is painted blue. How many square feet are blue? So on this one, I'm going to show a picture here. I'm going to come over to the right and draw the bottom of that swimming pool that's circular in shape. And it's telling you the bottom of that swimming pool has a diameter. So the diameter goes right through that center point there of 30 feet. Diameter, 30 feet. And so we need to know how many square feet the bottom of that swimming pool, how many square feet there are. Well, this is our formula, right? Area equals pi r squared. Apple pies are 2. Apple pies are 2. A equals pi radius squared. Well, we have the diameter, and in the formula, we need the radius. So we have to get that radius. So we're going to make sure right now we understand if I see the diameter is 30 feet, we need to cut it in half. We need half of that, half of 30. So the radius is going to be 15 feet. We need that for our formula. And so again, there's that comfort level of understanding what you're given and what you need to use in each formula. With circumference, we had to use diameter. With the area formula, we have to have the radius. And so this 15 feet is going to fit into that formula for the R. So let's start working it out. We're going to again use the pi key in this example. So we're going to do pi times radius squared. So the 15 feet that we just found for the radius goes in that formula, 15 squared. Now I said you have to use order of operations, right? So that means we need to do 15 times 15 first. 15 times 15. So square that number, multiply it by itself, and you should get 225. Now we're going to multiply that by pi. Okay, so we're going to take 225 on your calculator times, use the pi key. And you will see this decimal, 706.853, and it just keeps going. Rounded to the nearest tenth. Nearest tenth. So we look at the hundredths, we look at that 5, tells us what to do with that 8. It is absolutely going to round up. So your final area for that pool, the bottom of the pool, is 706.9 feet squared. Area of the bottom of that circular pool. Okay, so now we've tried an example where you've been given the radius in the circle and plugged it into the area formula. We also just now did an example where you're given the diameter and you have to find the radius to use the formula. Okay, so one of each. Now I'm going to have you try a couple. So you're going to go to the guided practice. And on guided practice, you're going to see number 1 and number 2. And this is on page 626. And you know what? You can also do number 3. You just don't have a visual here. But if you want to draw it, right, you can do that. So this one's giving you a diameter of 16 meters. Okay. You try those 3. Now in these 3, what I want you to do, instead of using the pi key, I want you to use 3.14. We're not going to use the fraction form of pi. We're not going to use the pi key this time. We're going to just use 3.14. So we're going to use the abbreviated version of pi, and you're going to round to the nearest tenth. Okay? So if you need to, you can write down again what the formula is. So you have it right in front of you. Area equals pi r squared. And I'm going to have you try these 3 right now. Just remember, 3.14 is going in for pi this time. So pause the video, try those three, find the area on those three, and I'll meet you back with the answers. Okay, taking a look at 1, 2, and 3. Number 1, you should have gotten 78.5 centimeters squared. That's to the nearest tenth, and using 3.14 for pi. Number 2, the area on that circle is 153.9 inches squared. Number 3, you were given the diameter to start with. You needed to find the radius for the formula. The radius is cutting that diameter in half. So half of 16 is 8. So you use the 8 meters for your radius. And so when you do that, you should get an area of 201 meters squared. So we're going to stop here today, and then give yourself some time, if you still have some time in class, to finish up some ALEKS that you need to for the week. Or if I bring the agenda back up, maybe, there it is. If you need to do anything in the Chapter 8 graded checklist, okay, if you still are behind here. So have a fantastic weekend, and we'll see you back on Monday.